Hi, y'all. Howdy. Welcome back. Today we are we're talking about topic for day 2, which is solving inequalities. All right. So you guys have done this before. You did this in Algebra 1, you did this in Algebra 2. So hopefully this will just refresh your memory. So we're going to talk about linear inequalities, and then we're going to talk about absolute inequalities. All right. So in case you forgot, an inequality has to have one of these four symbols: less than, greater than, less than or equal to, greater than or equal to. All right. And whenever you divide or multiply by a negative number, the inequality must change. So you have to flip it. Okay. So if you divide by a -4, you got to flip that symbol. If you multiply by a -4, you have to flip it. Okay. Any negative number, if you divide or multiply it, you have to flip the symbol. Okay. So let's look at this first example and see if we remember how to do this. So just imagine the inequality is an equal sign, right? We're just going to solve this the same way. So we need to get all the x's on one side, all the numbers on one side. It doesn't matter which side you do what. Okay, it makes no difference. So I am going to start this by subtracting 2 from both sides. If I subtracted 2, that would leave me 7x greater than 4x plus 13. 15 minus 2 is 13. Now I got to get that 4x to go to the other side. So I'm going to subtract the 4x. So I get 3x is greater than 13. And then I have one last step, which is to get the x by itself. So divide by 3. So x is greater than 13 over 3. That's it. So any number bigger than 13 thirds, 13 thirds is like 4.33333333. Okay, so anything bigger than that. All right, one of the things that you might be asked to do is to graph this. All right, so if we were to graph this just on a number line, right? Now I only put the numbers that I need, right? I don't fill in every single number. So I always have to have 0 on a graph, and then 13 thirds is a little bit bigger than 4. So I'm going to put a 4 here, and I'm going to put a 5 there, because 13 thirds is between 4 and 5. Okay? Notice that this doesn't have the equal sign under it, right? So if you remember back to your Algebra 1 and Algebra 2 days, whenever there is not an equal sign under it, we are going to put an open circle. And I always do it a little bit above the graph. Well, I'll do it on the graph this time. So I put an open circle. So I put a circle at that value, like 4.333, okay? And I want x is greater than that. So that means everything to the right is our answer. So I just kind of squiggle it in so I know my answer is any number going that way. So 5, 6, 7, 5.5, 5.1, whatever it is. Any number bigger than 4.333 would work for this problem. So no matter what you put in, as long as it's bigger than 13 thirds, that will be true. Okay? And that's it. Just solving inequalities. So now we're going to do one that's a little bit harder. We're going to solve this one. All right? Again, it's just our basic algebra facts that we did in Algebra 1 and Algebra 2. We have to start whenever there's a number in front by distributing. So I am going to have to distribute twice because I have 2 numbers in front of parentheses. 5 times 8 would give me 40 minus 10t. The inequality hasn't changed. 2 plus 16 times 4 would be 64 plus 16t. All right. And now I can combine 2 and 64. 40 minus 10t greater than or equal to 66 plus 16t. And now it's just like the last problem. Get all the letters on one side, all the numbers on one side. So let's see. I'm going to subtract 40 just because. That's what I wanted to do. So the 40s cancel. Negative 10t greater than or equal to 26 plus 16t. Then I got to get all the t's on one side, so subtract 16t. So negative 26t is greater than or equal to 26. And now there should be like bells going off in your head because you already know that you're going to have to divide by negative 26. And you should be like, I think I'm supposed to do something here. and negative 26 will cancel. 26 divided by negative 26 is negative 1. But since we divided by a negative number, this symbol has to flip. That is my final answer, right? We have to flip the symbol whenever we multiply or divide by a negative, okay? And if we were to put this on a number line, I always put 0, and then I just put the number that I need, negative 1. So this one has an equal sign under it. So that means at negative 1 is going to be a filled in circle, right? This one didn't have equal under it, so I made it an open circle. This one does, so make it a filled in circle. And t is less than, so less than means we go left. So that's everything over here. And again, that just keeps going forever and ever and ever. Never stops. All right? Hopefully you all remember this. Hopefully as you're watching this video, you're like, oh yeah, I remember that. Okay, the last part for today is now absolute value inequalities. So the very first day of this class, last semester, we talked about absolute value equations. Okay, this is going to be basically the same thing. Okay, remember, whenever you do absolute value, you have to have two answers, two cases. One where it's positive, one where it's negative. Because absolute value, it could be a negative number inside, it could be a positive number inside, and you're still going to get the same answer. All right. So this one's pretty easy, right? There's nothing in front of the absolute value, nothing behind it, so we don't really have to do a whole lot. So one of my answers is going to be x is greater than or equal to 2, all right? Or I could have another answer where x is less than or equal to negative 2. Notice the difference. The only thing that changed was this 2 became negative, and since I made that negative, I had to flip the sign. Okay, it's like I divided by negative 1, so that sign has to flip. Okay, and so I'm done. X is greater than 2 or x is less than negative 2. So again, if we graphed this, if we were to graph this thing, right, I'm going to put 0. I always put 0, negative 2, and positive 2. They both have an equal sign under it, so I'm going to fill in both of the circles. One here and one here. It is greater, x is greater than 2. So that would be this direction. And it's less than negative 2. So that would be this direction. So any number between negative 2 and 2 would not work for this problem. But any number bigger than 2 or less than negative 2 would work. And it would make this true. All right? Okay, the second one. Now we have a little bit more work to do. Okay, there's nothing in front of the absolute value. There's nothing behind it, so I don't have to get it by itself yet. The absolute value has to be all by itself, which it is right here. So it's already set up. So I can do my two problems. 2x minus 1 greater than 7, or 2x minus 1 is less than negative 7. Okay. First one, nothing changes. Just get rid of the bars, absolute value bars. Second one, in this case, change the right side to negative. Just do the opposite and flip the symbol, and then just solve it. So we would add 1, 2x greater than 8. I don't think you guys will have any trouble with this. Divide by 2. X is greater than 4. There's the first one. Now do the same thing over here. Add 1. 2x is less than negative 6. Divide by 2. X is less than negative 3. Bam. So there's our two answers. X could be greater than 4 or less than negative 3. And once again, if we graphed it, so let's see, we'll put negative 3 here, we'll put 0 here, we'll put 4 over there. They don't have an equal sign under it, so they're both going to be open circles. Open and open. It is less than negative 3, so that's this way. Less than means go left, and it's greater than 4, so it goes that way. All right? Okay, we have one left. Now this one is a little bit different because now notice there's a 9 in front. I cannot split up my problem like this. until the absolute value is by itself. All right. So I need to get rid of that 9. If there was something after it, I would have to get rid of that 2. All right. So the absolute value has to be all by itself like it was in these two problems. So first, let's get rid of that 9. We're just going to divide both sides by 9. So absolute value m plus 1 less than or equal to 4. Notice I didn't flip the sign, right? Because I divided by positive 9. All right. Now this is ready to do what we did on the last problem. So m plus 1 greater than or equal to 4. Do not change anything for the first one. Or m plus 1 is greater than or equal to negative 4. Change the sign and flip the symbol. All right, and then we just solve it. Subtract 1 less than or equal to 3. Subtract 1 greater than or equal to negative 5. So there's our answers. Bam, bam. And if we wanted to graph it, this one's going to look a little bit different, which is why we're going to graph this one. So let's say negative 5 is here. Let's say 0 is here. And let's say 3 is here. These will both be filled in because they both have equal under it. So fill in that one. Fill in that one. M is less than 3. So that means it goes this way. Less than 3 goes to the left. But it's greater than negative 5. So greater than means go to the right. So now the answer falls in between these two. So the answer has to be in between negative 5 and 3. Anything else, it wouldn't be true. But any number in there, any decimal in there, anything would work for this problem. Okay? That is your topic 4, day 2 inequalities notes. If you got questions, please reach out to me. I appreciate y'all. Thank you.